All right. Um, so we see that nowadays DevOps is it's the hype. It's a new thing, and to see there is DevOps has a goal. It has in fact multiple goals. So one of the goals is faster time to go to market. And when one wants to go to market early and release multiple cycles as early as possible, it is imperative that the testing has to be continuous. So to ensure good quality. So today's session is on the continuous testing in DevOps, how it can be done, how it is different from that. So Madhu is there with us who will explain that what is continuous testing, and I would like to just take a minute to introduce Madhu for whoever is joining the webinar for the first time. Madhu is one of the testing veterans and the leaders in this testing industry, and he has worked at a very high profiles with a lot of corporates, as well as he's an entrepreneur. So, welcome, Madhu, and let's start on today's session. So, Madhu, we would like to know that how continuous testing is any different from any kind of regular testing, right?
Okay. So, thank you very much, Swagat, and also thank you very much, everyone who has joined. Very good morning, maybe good evening, from wherever you have joined. And also, I don't have kind of knowledge of who is attending the session, but I'm expecting that a lot of practitioners, both from testing space as well as the development space, have joined this webinar, and also a lot of fresh graduates who are aspiring for first time good jobs in the IT industry also have joined this webinar. So as usual, please feel free to ask any questions that you may have, and we will take some 35 to 45 minutes to explain this topic, continuous testing in DevOps. I'll interact with Swagat, and we'll make it as much interesting as possible. Please feel free to type in your questions so that we can make it a very interactive question. Give your suggestions, make your comments, do your criticism. Let's make it a very highly interactive session. That's the goal. I'm very happy to be part of devop-trics. So yeah, Swagat, you have asked what is this continuous testing and within the DevOps. Yes, actually, we are seeing a lot of change these days, especially with the digital transformation taking place rapidly. We are, as an industry, we are building a lot of new digital business processes on top of the legacy enterprise business process, and especially the emergence of SMAC technology stack, the social, mobility, analytic, cloud, and coupled with Internet of Things and artificial intelligence, machine learning, we are able to kind of imagine a whole new range of applications and efficiency. And also, along with this technological change, the speed at which these applications are taken to the end user, and that has become extremely important for the software industry now. Whoever is able to take it fast and reliably to the end users, they are the leaders now. So in that, the DevOps culture, the agile movement have significantly helped the software teams. Now, coming from the testing backgrounds, we came from a little bit of old school thinking. At least I came from a old school thinking. Somewhere in 1995, I started as a testing manager for a ERP software company. During those days, quality is extremely important. Today also quality is important. Those days also quality was important. So I used to always get into arguments with some of my development manager counterparts. So I always used to argue that quality should prevail over schedule. Means quality is more important than meeting the deadline. Whereas the development managers used to argue schedule should prevail over quality. So always this kind of arguments we used to indulge in. So in a sense, why we used to talk as test managers during those times, that quality must prevail over schedule, because if a bad quality goes, a huge reputation loss happens. So in a kind of old school thinking of testing, always relied on, yes, testing improves quality, but the counter argument for testing is that, okay, but it reduces delivery speed. So always that compromise was being done. But in today's context, in the digital transformation era that we have, the mantra is quality at speed. So today's need, it's not just speed, it is not just quality, it is quality at speed. That kind of mind shift change is putting a lot of pressure on the way we are testing, and also the pressure on the test managers, the test leaders, including the development leaders and also the scrum masters of agile teams. So today's need, it is not just speed, it is not just quality, it is quality at speed. That is the mind shift change that is taking place. So now, in the center of all this, quality has become important. So people started talking in the agile DevOps with a prefix that is called continuous development, continuous integration, continuous delivery, continuous quality assurance, continuous verification, continuous monitoring. And anyway, testing people, we will not lag behind all these folks. So we started adding the prefix to testing as well, and we started calling it as continuous testing. And everyone agrees in the industry, all the gurus are telling that continuous testing is critical for DevOps success. So that is the goal, or that is what we will talk today. So a lot of people still today tell that, okay, a lot of hype is happening about all this continuous everything. So we may agree with them, yes, because these are all the new things that are coming up and changing the overall the way we were doing things. It may be a hype, but in recent, like soon, it will become maybe very important for every test engineer, every development engineer, every ops engineer working in agile DevOps kind of environments to understand this continuous everything aspect. And also, especially from the agile scrum team point of view, the most important point is continuous testing. So we will try to understand this as you asked. So please interrupt me and keep asking questions, Swagat. So hope you kind of got why it is important for all of us to talk about continuous testing. Swagat.
Yes, Madhu, thank you so much. That explains what is continuous testing. So, just I had a follow-up question on this actually. So now when we say that continuous integration, continuous delivery, so how does this continuous testing fit into that?
Okay. Yeah. So first, actually, to understand this continuous testing, let us understand that word, because I always try to understand these words. Continuous means uninterrupted. So continuous testing is uninterrupted testing. So if we are talking it as a new way of testing, so we need to let us look at actually the old way of testing. So the old way of testing, we used to refer it to as a handoff centric oriented testing. Means sometime now anything that needs to be continuous, there should be an object that has to continuously move. So what is that object that we are talking? Here, the object is a software or a changed software. And usually we call them as any changed software or a new software. Once it is compiled, built, it becomes a software artifact. And if it passes some basic kind of tests, we call it as a release candidate. Now, the release candidate, the software, has to move from the time a change is made on a desktop of a development engineer till it lands in a deployment environment or in a production environment. That release candidate continuously should move. That is the real thing that we are talking. That has to be continuously developed, that has to be continuously delivered, that has to be continuously tested, and that has to be continuously deployed. So the release candidate is the object that has to continuously move, and as development engineers, as testers, as ops people, we are all working towards moving that release candidate continuously from the time it got created or got changed till it gets deployed, and then again back, take the feedback and again keep changing and be in that uninterrupted kind of movement around your software release candidate. So quickly, because you asked how is it different, let me, even a typical agile team in a traditional way, the way we test, not so in continuous way, we call that as handoff centric kind of testing. Then typically what happens, a product owner, maybe he or she creates some user stories and checks with the business and hands them over to a development team, and then the development team in a sprint, they write some code, maybe they write some unit tests, run them on that, and then also, then once they are satisfied from a technical point of view, the code is meeting the requirements stated in the user stories, they hand over that software to the testing team, and testing team in an offline conducts their own testing, and they investigate a lot of issues, and then they return back that information to the developer. Then that is how, even in a traditional Scrum teams, in agile environments also, testing is happening. So now, when quality at speed is your goal, and you want to kind of get into a situation where every release candidate at any day I should be able to put into deployment, then I may have to reinvent the way I'm actually running my software engineering itself. That is where we are talking about this CI/CD pipeline and deployment pipelines. These are the like modern agile teams which are matured. Before they start developing the software, they kind of design, develop their CI/CD pipeline, and they instrument that pipeline, and then they start working, and they kind of orchestrate and do everything automation, so that from the time a change is made to the software till it is deployed, a lot of automation comes into place. So looking at this graphic, so typically in a little bit continuous testing mode, what happens? So yes, developers take the features kind of prescribed in the user stories, they code it, and as they code, they check all the changes to the software or the net new software into the source control system. And once code is checked into software configuration management environments, then the CI servers come into place, and they will trigger a build process, and as soon as it is compiled and the software was able to build correctly, then automatically they trigger a set of unit tests that have been created by developers, and also maybe some static code analysis they conduct based on whatever coding thing they're using. Then once within the CI environment, a build has been accepted using a good set of unit tests and a good set of static code analysis checks, then we call that as a release candidate. And this release candidate now will have to be deployed into different type of environments. Again, we may do more testing after deploying the release candidate into a development environment and test a particular type of test. Then also we may deploy that release candidate into a QA environment, and QA people can do some business facing, business critiquing testing. Then maybe a set of people conduct, after deploying the release candidate into another environment, conduct performance testing there, and then it will be deployed into production. So this whole chain of events, if they are kind of happening in an uninterrupted way, in a continuous way, then we are calling it as continuous testing. So just to kind of explain how people are defining continuous testing, I took a definition from Forrester here. So Forrester defines continuous testing as its people, processes, and technology to deliver quality at speed. So quality at speed is extremely important, and while we are achieving that quality at speed, the whole process must mitigate the business risks. The risk management, risk mitigation is very important. We'll discuss about this point little later. And conducting all agile testing activities in parallel to and in an integrated fashion, from ideating, planning, to building, to integrating, to delivering, to deploying features into production. The whole chain has to be continuously moving. And in the earlier testing, we always stopped testing or development related activities as soon as software is deployed into production. That became some other people's concern. But in a DevOps kind of environment, in a continuous delivery, continuous integration, continuous testing environment, post-production tests also become very, very important. So in this definition, Forrester very carefully put that quality at speed is important. Business risk mitigation is extremely important. It is not that because of speed, we don't care about the quality. And when we care too much about the quality without analyzing risk, we may not have speed. So the risk issues getting involved into that, and then not stopping testing once it is deployed, but actually after it is deployed, monitoring and alerting and taking action on those things is becoming very, very important. So if you look at from this again graphic, so continuous testing, it runs parallel to and integrates with Agile and DevOps. So if you look at this graphic, it all starts with planning, coding, building, testing, and releasing the software, and it goes some more tests there, and then it gets to deployment. At the deployment time, it gets tested, and as it is operating, then again it will be monitored, and the feedback is kind of coming, and it will keep on happening. And continuous QA is kind of runs parallel, and it integrates with Agile and DevOps. So what are the objectives of continuous testing? So if you look at it, the first point is that it must meet the demanding requirements of Agile development. So if you look at Agile development, actually it has transformed testing in a lot of manner. So earlier we used to have very well-defined testing types, testing levels, very well articulated entry-exit criteria, a systematic, structured approach we used to follow. We used to call it as the fundamental test process, and it used to run sequentially. But now Agile has blurred all those aspects, and within the 3-week or 2-week sprint, all levels of testing, all types of testing, parallelly, they keep running. And in fact, the Agile testing gurus have actually brought something called Agile testing quadrants. Every test engineer must understand the Agile testing quadrants, because the Agile testing quadrants, they're talking about a set of tests that are technical or technology facing tests that support the development activity, and another set of tests, they are business facing tests that critique the project. So all these tests, some of them have to be done by developers, some of them have to be done by business people, some of them have to be done by testing people, and a lot of things have to be automated, lot of technical tests have to be brought towards the left. So Agile itself has changed the way testing is performed in projects. So there is a lot of focus on test automation and also applying exploratory testing practices. These are very, very critical things for continuous testing. Those are very critical for Agile testing as well. And again, driving good design and development and shift left to build in quality. Like, for example, good design is very important for good continuous testing. If you develop an application with a good API interface, then even the graphical user interface is not ready, then we'll be able to think about some test automation and build those test automation very early in the life cycle, even before the real code arrives. So all these are important objectives or we need as testing teams to look into these aspects. And the second point is the continuous testing must meet the business requirements for quality. So quality must keep keep pace with the accelerated release cadence. When we are talking cadence, cadence is a rhythm. Now, earlier, software is used to be released 4 times in a year, means once in 3 months. Now, a lot of companies are large enterprise IT organizations. They're trying to achieve once in a month. Some people are trying to achieve once in 15 days. So, as you establish more accelerated rhythms, quality also must keep pace with it. It's not just okay, I'm able to do once in a month release, but if the quality is bad, actually in this kind of consumer world, immediately our reputation will come to a big problem. So quality has to must keep pace with it. That is very important requirement of continuous testing. And also the QA people, whoever playing QA role, they must collaborate with product owners very early in the life cycle, identify the business risks, and so again set very good, well articulated quality gates that can be automatically kind of verified, and these are very, very important kind of objectives of continuous testing. And continuous testing must be designed within the context of the CI/CD journey that your agile team is taking place. So whatever testing, unit testing, functional testing, performance testing, security testing, all of them are important, and they have to happen iteratively, progressively, and comprehensively, so that unlike your traditional kind of testing, you have to iteratively, comprehensively, and progressively, you have to keep on developing. So the whole team has to participate in that. Now, the continuous testing, it is not just the responsibility of a testing team only, or a team that is playing testing role. So again, as a team, again, testing people have to play a significant role. They have to contextualize their CI/CD journey, and within that context, the CT practices have to be built. These are the various objectives of continuous testing. And again, continuous testing, it should support the additional DevOps needs. So again, as I told you earlier, in traditional testing, once we hand over the software to the ops people and they take it to production, then almost we are forgetting about testing, or we are not in touch with what is happening in the system. But in DevOps, actually everything begins there. Once it is deployed, as quickly as possible, we have to monitor the environment, production environment, and get a lot of feedback. And this feedback has to be very quickly used to improve the software and make changes and be on that continuous journey. So just to talk about the continuous testing in a holistic manner, what I did is that I'm telling you the importance of continuous testing, what is changed, why it is needed, and then how Forrester is defining continuous testing, and what are the main objectives of continuous testing. Swagat?
Yes, Madhu, please go ahead.
Okay. So anyway, you asked another question, that is how it all happens. So,
yeah, how does it fit in?
Yeah, how everything fits in. Yeah. So there is a wonderful book by Jez Humble and kind of Farley, Continuous Delivery. It's a real wonderful book. I recommend that everyone buys that book and reads that book. So they have explained all this in a very interesting way. So if you look at a software engineering team or an agile scrum team wants to start a continuous kind of journey. When I'm talking continuous integration, continuous delivery, continuous testing journey, they have to understand their engineering, their product's vision, their quality at speed goals, and build a basic deployment pipeline. When we are talking about basic deployment pipeline, means yes, there is a global team. Now, the team may be working in multiple agile scrum teams across the world, and again, they may be changing or building a technology on a very complex kind of technology stack, meaning there is a legacy aspect to the technology stack, there is a modern aspect to the technology stack, but any change done to this has to be systematically put into production. These are very simple to very complex environments we can have. So within your context, within your environment, think about a CI/CD basic deployment pipeline. So in a basic deployment pipeline, version control plays a significant role, and there is something called artifact repositories that play a significant role, and how much you will automate. Like everything has to be put into version control, like all the source code that is being changed, developed by all the teams has to get into a good distributed version control system. Your environment and app configuration scripts have to get into that. Your automation scripts have to get into that. Your unit test scripts have to get into that. So version control is a very important aspect of the pipeline. And whenever a change is kind of committed into the source control, if a CI kind of process is being leveraged, a Jenkins kind of server will every time poll the version control system, and as soon as change is committed, it starts building process, and so multiple builds will be created. So we have to create a shelf or a storing place for the builds, and that's what we are calling it as the artifact repository. But in between all this infrastructure, there is a lot of coordination, orchestration happens by triggering automatically some scripts. So if you look at it, the whole pipeline can be divided into multiple stages based on your context. The first stage is the commit stage, where as soon as developers make changes and commit the code, a set of tests, a compilation process happens, then some basic build verification tests or smoke tests, unit tests are run. We call them as commit tests. Then if it has to be kind of assembled with the rest of the things using Maven kind of dependency management will be assembled, and then also some kind of static code analysis happens in that stage. Now from that stage, once a build passes that, then a release candidate has been created, and our goal is to move to the next stage. The next stage can be potentially an acceptance stage. So what we do in the acceptance stage, so whatever this build, we are calling it as a release candidate, which has been compiled, which has passed some basic technology facing tests. Now that build we will configure in a test environment. We deploy this build, and there automatically we trigger some more tests. We do acceptance tests. Acceptance tests may be a typical more business facing end-to-end functionality tests we may run. Now, then actually once the release candidate passed that stage, now it has to move to the next stage. Maybe it will be again a new environment is configured. We let's call it as UAT, and in that again the build, the release candidate, the fast acceptance test will move to the UAT environment, from there to performance environment, from there to production environment. Now all these things can be fully automated from the time commit is done till it is deployed into production. But it may not be really important for every company to achieve everything like that. So, but you will have to decide till what stage we will make it continuous. So let me explain that by using a little bit of sequence diagram. So if you look at here, a Scrum team checks in code into the version control, and as soon as check-in happens, automatically it triggers build and unit tests, and this build and unit tests may run on a dev environment or within the CI environment itself. But in case the build fails, the unit tests have failed on the build, then we send back that failed build to the Scrum team again. So in this process, what happens? The Scrum team, as soon as they checked in the changes to the version control, they will not start another new activity in development. They will wait for the success or failure of the build. If the build failed, they will understand the reasons why it failed and they will fix it. Then only they will start the new activity. Let us say the build has now passed. Now when it passed, automatically few scripts will be triggered. If you, the way you have designed your deployment pipeline, let's say you have written some chef or puppet scripts where you are kind of building an environment and taking out all the past build and deploying it in a new environment, and then also you are triggering some automated functional tests and automated performance tests. So those tests will be run on a new environment. And in case they fail, again the build will be sent back. So now till the build passes this stage, developers will wait for next development activity. So once it passes, it goes. Now, if you look at this graph, this line actually is telling till here everything is triggered and orchestrated in an automated manner, and development team waits for the build to go to the next stage. Now, some next stages are user acceptance stage and release stage, and then let's say deployment stage. Then actually the manual approval will be needed. Here the testing can be more handoff centric. So that is where you have to understand. You have to understand your context, till what stage of my pipeline I want to kind of make it continuous process, and from what point still it is important for me to depend on handoff centric. So that is how I'm kind of differentiating. So these things. So very, very important is that automated functional and non-functional test stage must assert the changes that are working functional and non-functional level. So just to explain the continuous testing and the context in which continuous testing happens, this is what is explanation. You may ask any questions, you may write to me as well, but to make it, put it in a simple way, this is what we are talking. So, Swagat.
Yeah, Madhu. So, Madhu, I would like to summarize it in a way that I understood this. Okay. So what I feel is that the continuous testing is right from the very beginning. That not just the testers are doing it, but even the developers are doing it when they are unit testing their code, right?
Yeah.
So right from the moment that they say commit changes, or say even like create a new class and create some unit test, and they commit. So that time the tests are triggered that will test their code in a unit tested fashion. Then
so at that stage, as soon as new code or changed code is committed, and for that whatever unit tests are applicable, they are automatically triggered at the time of compiling and building by a CI server. But you have to write good tests, and using those good tests you have to assert. That is where the risk comes into place. If you write some light kind of tests and irrelevant tests, even those irrelevant light tests pass that stage and the build moves forward, then it will create more risk. So that's where actually the development teams will have to understand the nature of changes, and based on that, some impact analysis based on risk, and create the necessary and appropriate the technical facing tests. That is very important.
Great. So not just again the unit test. I think the static analysis tests, they are also integrated very well in a matured say delivery model. And even if somebody tries to check in a code which is not well written, it will stop it from going forward.
Yes, absolutely. In fact, today's engineering teams in the commit stage itself, they do good amount of unit tests. And nowadays people are using tools such as Sonar Cube for doing good static code analysis, and also a lot of security code analysis tools also, both open source and from HP. There is a HP 45. So, because in this fast-paced engineering environment, because you are making change and taking them to production as quickly as possible, and the distributed nature of software, you leveraging cloud infrastructure, security has become a very important aspect. So a good amount of security code kind of audits and analysis is done automatically. They're triggered at the time of commit stage itself.
Okay, great. And after this stage is passed, then it is taken forward and a build is created. It is automatically deployed on the server. So this is in a way a deployment test also, right?
Yeah. So whatever nowadays, as soon as the release candidate has been kind of proved on a development environment or within a CI environment, now yes, there is a good candidate that can be moved to deployment. Now, but I want to test it in a different kind of environment now, production-like environment as soon as possible. Now, earlier what we used to do, there will be a system admin team. We tell them, hey, system admin team, please configure a good production-like environment for me, and take this build and deploy it and tell me whenever it's ready. Now those days have gone. We can use the modern the tools and infrastructure as code practices and write scripts to create virtual machines, production-like virtual machines by running a set of scripts. The same scripts will be used to configure and deploy builds on many, many environments. Maybe the same scripts will be used in production itself. So that kind of thinking is coming in the continuous testing now.
Right, right. So that is where the tools like Chef, Puppet, Ansible, SaltStack, these are used.
Absolutely, absolutely, sir. Yes.
Right. And once this stage is also passed, suppose the build is deployed now, then the test will run for say API testing and the UI testing.
Yes. Now, a good question. I'll actually start talking about these things using the next slide. So now let's look at continuous testing from a testing practitioner point of view, or a development point of view, or even a fresher point of view who is kind of trying to enter the industry now. So what we have to really consider now. So first thing is that continuous testing needs different approach. The old approaches will not be sufficient. Different methods, different skills, and different tools. So what do I mean by that? Test approaches need to be reinvented. I'll talk in the subsequent slides how these things will be done. And again, very, very important thing, as you talked previously, if we have kind of decided that till automated acceptance test stage, I want to make my testing continuous, means they are triggered, and I will ask my developers to wait. If any problems occur, they have to wait. Now, what does it mean? Every time a code is changed and committed, then a set of commit stage tests run, and if it passes, it comes to automated acceptance stage. And now, if you have put automated acceptance test stage inside that continuous kind of loop, what happens? Your tests will be run very early in the life cycle, and your tests will be run very often. Maybe every day they will be run, or many times in a day will be run. So these tests will have to be run early and often. What does it mean to us? First thing is that good tests have to run. Because they have to be run early, because they will be run very often, so I will do some light kind of tests, then you are increasing your risk of releasing a bad release candidate to the production. So you have to mitigate the risk, at the same time achieve the speed issues. For that, speed is important. Speed of execution is important. First of all, if you only rely on manual testing, then you cannot achieve continuous testing. Because if you're asking your developer, hey developer, please wait till I tell whether this build is okay after completing my automated acceptance test. And if you rely on manual testing, if you do 5 days of manual testing to give feedback, you can't ask your development team to wait. So you cannot even ask your development team to wait more than 2 hours. It is unproductive. So these tests have to be run extremely fast. First thing I'm telling Swagat is that test automation is very important. You cannot rely on manual testing. And again, absolutely, closer a team gets to continuous testing, the more lines between roles begin to blur. Now, as automated acceptance test is put in within the loop of continuous cycle, then now it cannot be only sole and whole responsibility of tester. Everyone in the team has to participate. They have to develop these automated scripts, they have to automate them, and they have to analyze the risks, they have to mitigate the risks in a very continuous way. And the tests will be executed early and often. So there are new approaches that will be very important for both development teams and testing teams to understand and practice. These are ATDD, BDD based test design. ATDD stands for acceptance test driven development. BDD stands for behavior driven development. And also earlier days, we used to do performance testing very late into the life cycle. Once the software is kind of stable and we will put it into a production like environment and do a big gigantic performance testing which requires a lot of resources and also a lot of hardware. So those days have gone. Yes, still we have to do towards the end a good performance test, but you don't need to wait till that time to get feedback on performance of your system. That's where shift left non-functional testing. So if you look at the automated acceptance test stage, in that we not only assert the build with some functional business facing tests, we have to also assert the build with some performance tests, and tools such as JMeter are very handy to do that, and also they can be triggered from within your CI CD kind of environments using Jenkins. So again, as I told, new approach. Earlier we used to stop at the time of deployment, testing is over, but actually testing begins again from production and it continues from there. So to achieve all these things, as I told you, testing will become more and more technical kind of competency. So more companies now, they are telling that they have evolved a new role, and this new role is called software development engineer in test. The QA roles have been kind of, though manual testing is important, the manual testers also have to play software development engineer in test. That actually puts a lot of skill, competency, responsibility, upgrading them on the shoulders of practicing testers. And also, if you look at from a test automation tools point of view, there are whole range of new tools are coming now. The graphical user interface based tools like UFT, Selenium, and the old ways of using frameworks and automating them, they're still relevant in regression testing at the time of release. But when you do in sprint test automation, as I told you, tests will be executed early and often, and developers are waiting for the verdicts of these builds on these builds. So tests have to be executed faster. So if you depend only manual testing, or if you are depending on only graphical user interface based end-to-end tests, which inherently take a lot of time to get executed. So new ways of automating have to emerge, and that's where actually we started using more and more of unit tests, more and more of API tests, more and more usage of service virtualization testing capabilities to kind of shift left early all this integration testing. So these are all changes that are taking place, and to enable these changes, a whole new kind of tools are emerging, especially the leading players in the tool markets are like Parasoft, Computer Associates, and all the traditional tool vendors also are rapidly changing their tool sets. But as testing practitioners, as development practitioners, as Scrum team members, and as freshers, please note these changes that will kind of, as continuous testing gets more and more prevalent, all these things will have to be addressed. Swagat.
Yes, Madhu. So,
Hello.
yes. Is it Suprita?
Yes. Actually, I have a question.
Mm-hmm.
So, the main thing is, okay, we can automate almost all the test cases, but what about the test cases which cannot be automated, like CAPTCHA? Okay, it keeps changing. So, like, how do we proceed at that point of view?
Okay, so from
that is.
so when you talk about a CAPTCHA, so the general practice in the industry is that for testing purpose that is disabled usually, right?
Okay.
So that is like, we work with the dev team and we disable that for the test builds, and we like, we kind of surpass that. But if it is a must, like Madhu said before also, that in the when it is suppose in staging or pre-production, so a round of manual testing is absolutely a must, and manual testing cannot be totally replaced by automation ever. So at least one round of exploratory test that is need to be done.
Okay, so first we proceed with the manual testing and then the automation goes on, isn't it? Right?
In general, yes, but I mean, in the current setup of Agile and DevOps, we try to see the ways in which the automation can be done as early as possible. Yes, absolutely. Some kind of manual testing will definitely go ahead when even you are designing your scenario, right? So you will actually
Okay.
execute the scenario manually. Then only you will automate, right?
Okay.
But we
Yes,
will
yes,
have to see
yes.
that how maturely we can automate. So that is where, if you avoid the GUI as much as possible, the better and robust your automation scripts will be.
Okay, but is it like, for example, if you take a forgot password page, okay?
Mhm.
Uh, Hello, can you hear me?
Yes, yes.
Yeah, for example, if you take a forgot password, for example, you entered a mail and you entered a wrong password. Okay, you'll be getting a to reset a page. So sorry, reset your password.
Hmm.
So in that you will enter all the details, and that you will get the capture, right? Isn't like how can you say it's a GUI? It comes under GUI, right? So how can
Yes.
you proceed? Like it is a must one. You can't avoid it, and you can't. Avoid it, right? So how can you proceed in this way then?
Okay, so there are a couple of techniques to that. So first is when this test is kind of okay, let's say that we have manually tested this and it has been working stable, right?
Yes,
So for
yes.
every build, you don't really need to test that. If it has been stable
Okay,
and no changes have been done on this area of login, so
okay,
login is typically not the see, it will be required to log in to the application to go ahead with any other scenario. But this forgot password
okay.
scenario, it will not be your ideal case for your regression testing or every smoke test, correct? So
Oh, yes.
when you do a risk-based approach, so you might leave this scenario out of your automation suite, or you might have
Oh,
some typical test cases specific to this, which you can automate, or we can run once a week or something. I mean, see, again,
oh,
it's a mix and match of how we plan our automation, what all tests we run, what our risk based approach we take to decide which test will be run on every build. Okay,
okay,
so
okay,
that's how we need to plan and design our automation suite itself.
okay. So if the that if that case is stable when comes to manual testing, if that case is stable, you need not go all the time for it, right?
Exactly.
So, such a test case. And previously, Mr. Madhu has prescribed uh, a book, yeah, book name. So, can you
Yeah.
please let me know what was that?
Yeah, that is actually continuous delivery by
Okay.
Jess Humble and David Farley.
Oh, thank you so much. Yeah.
I recommend you buy this book and read it. Why I'm
Sure, sure.
stressing that nowadays people are not buying books. So actually I want people to buy books. That habit is really good at.
Okay.
Yeah.
Okay.
Okay.
Okay. Okay.
Okay. So
Thank you.
let me continue then. But thanks, Suprita, for actually asking the question, making it very interactive.
Very good
So
question, in
yes,
fact.
lot of tests cannot be automated because again we are talking about three things actually when we are talking about continuous testing. In fact, I'll show a slide on that. There is one
Okay.
thing about sprint testing. Means within the sprint, as the new changes are happening, user stories are being realized, we have to ensure that with the right type of technical tests as well as business facing tests, we are asserting changes that we are making to code almost daily basis and manually as well as automating as early as possible. Again,
Okay.
if kind of put some of these tests in the continuous cycle, these tests have to be run extremely fast. Then actually we have to look at possibilities of reducing, not using a lot of tests that used to be our approach for regression testing. Everything that is available, I'll put into my regression suite. That may not be a
Hmm.
wiser approach right now. It has to be more risk-based subsets kind of suites only have to be selected that really assert that build at that particular time with good tests. And as Swagata mentioned, yes, API, unit, other touch points of the app is very important. And good, mature agile teams are actually perfecting this approach called BDD approach, behavior driven development. So at the time of defining your user stories at the time of describing your acceptance criteria, using what we call specification by example. Lot of test scenarios, feature files can be developed even before the code is written. That is using Cucumber and some Gherkin semantics. A lot of teams are actually capturing these behavior definitions into a set of files that is actually human readable higher level DSLs, and these DSLs can be kind of integrated in intelligent way with Cucumber kind of frameworks, and tests can be created early in the life cycle. So all these changes are happening. Some teams, I think, they perfected, but a lot of teams are still figuring out. But very important for all of us as testing practitioners is that this change, whatever continuous testing, is no longer a hype. Some mature organizations are able to achieve some great things by this, and more Scrum teams across the world are eagerly trying to embrace this. So that's where actually we have to look at this. So I'll move on to the next set of slides, Swagata. The critical success factors are, to put simply, how aspect of achieving continuous testing. Again, these are our thoughts very early in the life cycle, as we are also not experts, because this is a upcoming field. Our goal is to really share and kind of interact with other practitioners, and also be kind of provide some inspiration to the youngsters, the freshers, to get into this field. So as I told you, as testing teams, you have to reinvent what we call the continuous QA methods. The old traditional QA methods that we are all good at as testers, we have shown a path to our organizations. Still, they are relevant, but they may not suit the demands of the continuous testing. So, broadly put, the new strategy should, now we cannot create a handoff centric test strategy and try to retweak it, change a little bit, and try to use in a continuous delivery kind of mode or continuous testing mode. Those things will not work. That's why you have to arrive at a new kind of continuous test strategy. And within that, maybe another important thing is that as testing team or as development practitioners, at the initiation of the project itself, you have to kind of analyze and design your own CI/CD pipeline based on your objectives of quality at speed. What is the cadence, release cadence that I need? What kind of risks that I may have? What deployment kind of frequency I have to achieve? What kind of number of releases I have to make per quarter? All these things will decide or help you decide the overall analysis and design of CI/CD pipeline. So your overall method should contain that. And after having done that, in collaboration with the rest of the business, the ops people, and the Scrum team, you have to develop your own CI/CD pipeline and figure out a way to operate it. Why I'm telling you that in a small team, less complex team, these are very simple. But imagine you are working in a large enterprise IT kind of situation where there are 300 to 400 global Scrum teams work every quarter, make changes, and the technology stack is extremely complex. A certain part of the stack is mainframe, a certain part of the stack, the middleware, using some kind of SOA technologies, and the front ends are mobile, web. So in such a complex technology stack with a large scale change that is taking place, you have to kind of put this CI/CD infrastructure and make it available to your global teams and use it in a good way. For that also, teams will have to establish some good methods. So that is one thing. And as I told you, when we are talking about continuous testing, there is an aspect of in-sprint testing. During the sprint, there is a continuous testing that happens, and there are aspects. Once all the changes done by all the Scrum teams, it goes through a phase called release, where more traditional kind of testing happens. There, what is our approach? And then once the software is deployed and moved into production, what kind of new things have to be done. So all these things will encompass our continuous QA method. So all the testing practitioners on this webinar, all the freshers on this webinar, please keep in your mind that continuous testing needs us to reinvent new methods, or the old methods, tweaks of old methods may not put you in good stead. So that is why keep that in your mind, just to enable you to think only. I have kept it. And another very important thing is that the traditional testing skills will not suffice. Yes, those are important. We are not telling that in sprint or release testing, manual testing will vanish. A lot of tests can be only manually tested. A lot of good defects can be found only by manual testing, but more and more exploratory approach to manual testing will evolve. So your testing foundation, your agile testing concepts, your exploratory testing, they are fundamental to any testing practitioner. But along with that, you have to also be more technical kind of person now. You have to learn at least a programming language or two, then learn at least Selenium kind of tool and one XUnit framework, so that you are becoming more automation person. Not only that, the newer concepts to shift left, a lot of early testing, we need to get hands-on with ATDD, BDD frameworks, and all these DevOps tools or continuous integration, continuous delivery tools such as Jenkins, Nexus IQ, Urban Code Deploy. All these are very important tools we have to learn. And also, again, in testing, what really wastes testing time and creates a lot of wait time is the test data availability or creation of that, the test environment creation and availability of that. Using these new tools, deployment technologies like Chef, Puppet, Vagrant, Docker, this infrastructure as code, also you must learn, so that you are able to create your own environments and your own data on the fly. And also in a large kind of context, you are able to create test data as a service kind of mechanism, or test environments as a service for a larger team to do work more efficiently. You must be hands-on with this technology. So my point here is that continuous testing will affect this, each traditional tester. So you have to kind of look at critically the skills and competencies that are needed to kind of stay relevant in this new kind of area. So I suggest all of you reflect on this and make some kind of choices, start learning incrementally. So that's my recommendation to all practitioners as well as the freshers who are aspiring to get into testing space. There is no the traditional tester role in the new IT organizations now. It is more of a SDET skills. So freshers, my recommendation to you is that don't go after those old skill trainings, some silly training institutes with some silly training programs. Be critical about it. Take guidance from your seniors. A lot of practitioners are there in this webinar. They know and they're experiencing every day. So even practitioners give right advice to the fresh engineering graduates. Somehow this knowledge is lacking in the industry. So please play your role to explain about the new set of skills that are needed. So as Suprita also asked, the other things that as some critical success factor to achieve CT kind of thing in your teams. One more thing is that the test automation strategy needs to be readjusted to meet test early and test often objectives. I've been talking about this test early and test often. So when we are talking about test early and test often, the tests have to be extremely reliable. The tests have to be extremely relevant. And the tests have to execute very, very fast. So how do we achieve this? So to achieve the speed objectives, the goal is that don't depend on time-consuming graphical user interface tests only. They are needed. Any tests that are end-to-end from a user point of view we are doing, those tests must be used in your automated acceptance tests. They are having their own kind of importance. But a lot of things can be achieved without using GUI interface also. So there are automated API tests. and automated integration tests using TestNG kind of frameworks, automated unit tests using XUnit kind of things, and protractor kind of tools. And if you look at this graphic, use more and more of fast executing tests, okay, in your automation suite, and use fewer of the tests which are time consuming. If you look at it, the manual exploratory tests are important. They have to be used for finding defects, and they consume a lot of time, but they are important. So use more fast executing tests and use less of the slow executing tests. Then you will execute the test faster. And I told also dependable or reliable tests are important. Most of the graphical user interface test automation fails because, let's say you have a suite of 100 tests, they run for 5 hours on a build, and it throws up some 100 problems. And when you analyze these 100 problems, 95 of them are actually not really problems related to software. They're problems related to the configuration. They're problems related to your tests itself. So they're all some false positives. Only 5 are very relevant. So though automated execution took 5 hours, somebody to look into these 100 results and establish that 95 are useless, it will take another 16 hours. So reliability of automated tests is important. A lot of organizations, a lot of seniors don't like automation because they are not dependable. So building robust test automation, sometimes using GUI approach, the graphical user interface approach, is difficult. So that is why also these other aspects have to be used. And then I told always to execute with speed, don't maximize your regression tests, you optimize. And what is the principle for optimization? Good risk-based analysis and a good selection of subset of regression tests that assert a particular build at a particular time is an important thing. All these things are very important in the way you are approaching test automation when you want to achieve the test early and test often objectives of your continuous testing. And last slide that I want to talk is that even who will participate in automation is also an issue in continuous testing. So in continuous testing, test automation will no longer be the whole and sole responsibility of testers. Everyone will have to participate. So the developers participating in this webinar, I am observing more and more engineering teams, the test automation responsibility is being shifted to the development team. So typically we call ourselves as an agile scrum team, but how in sprint work happens, there is a development team, or the team or the people who are playing development role, they are more focused on developing the code, and the testing team the people who are playing test role are taking the responsibility of test automation. And when this test automation begins, only when a sprint change has been done and manually it is verified and some semblance of stability is achieved, then only people think about starting automation. So we are creating a silo within the Scrum team, and the test automation is always lagging behind by 1 or 2 sprints. Then we will not be achieving continuous testing, because till the time testing will be only manual, and manual testing is time consuming. Then you may not achieve your risk mitigation objectives during your in-sprint continuous testing. So teams will have to figure out a way to automate very early in the life cycle. That's where I responded to Suprita also. People will have to look at BDD as an approach. That's again a cultural change. It has to be systematically learned, but I think those approaches will help, and the whole team has to participate in test automation. So test automation is collective responsibility of the Agile Scrum team. These are the changes that are taking place. And with this, Swagat, I'm kind of, if I have to give a recap, we told what is continuous testing, why quality at speed is extremely important in the new digital age, and within the continuous everything, how critical continuous testing, DevOps success is dependent on continuous testing. Then we try to understand what is really continuous testing and how kind of we can achieve and what are the success factors to achieve that. So Swagat, let us open up for
Yes.
questions now.
Sure. So guys, please shoot your questions. You may either type your questions in the chat window, or you can be verbal about it. Both ways are fine. I think yes. So many you're trying to say something. Please go ahead.
Hello, this is Shogun actually. So,
Yes, please.
I am actually a test automation. I am actually a test automation engineer.
Mhm.
So actually, I was interested about learning about DevOps and everything. So in our organization, we are following for DevOps. We are using Jenkins in our ecosystem.
Mhm.
But I was thinking of something new, some introducing some new tool. Actually, my question was in the ecosystem, like we have Selenium framework, and with that we have Jenkins. So in that current scenario, if I want to introduce something new to our organization, so what kind of tools we can introduce? So that was my question.
Okay.
For achieving DevOps or
Okay.
CI/CD, you can say.
All right. So now, Soman, good question. Now, I would like to ask you a little bit in detail that what is that you are really looking for? Now, if you are looking for automating the say deployment also, okay, on a remote server, you might consider tools like maybe Chef, Puppet, or which are good in infrastructure management through code, okay.
Okay. Okay.
But if you are just looking for say test automation, right, and you want to continuously test and keep sending the information to the developers, I don't know whether you are right now integrating any API test or not. I think you should be seriously looking at it, at those options apart from GUI test. Yeah, Selenium is good for GUI test, but API test is a very very important thing. Yeah, go ahead. Tell me.
API test, we are yet to cover it, but yes, API testing is very much in market, and we want to introduce it. So my question was, I'm trying to learn API testing actually using Sophia or Postman something. But if I want to introduce it in DevOps environment, so my question was, I am not very much aware of it because I'm just learning about it.
Okay.
So my question was, fine, we have Selenium Jenkins, that is fine, but if, you were saying API and everything. So what kind of tool we should study, or what kind of infrastructure we should study?
Okay, so from that perspective, I would say that okay, you are doing the GUI automation. Okay, now focus a little bit more on the API testing, service virtualization type of tests, for which you can use REST assured library within Java. If you are using a Maven project, it should not be too difficult to get started with it. Okay, and apart from that, yeah, I mean automating a unit test are very very important. So talk to your dev team about what they are doing for the unit test. If at all they are doing something great, if not, then you can probably extend some help that okay, if we can help. If you get the access of the dev code base, you can start writing some unit tests to just test out the main classes that they have.
Okay, but we don't think that we'll be given that permission to access dev codes, because we only we can have the output as a build, which will be deployed in a server. So our testing starts from the build itself. So I think apart from GUI, I was listening all the whole webinar, and every sir was saying he was saying that only GUI testing is not enough, so we need to think beyond that. So that's why I am thinking to introduce API or service virtualization that you are thinking. So fine, okay. So if I have some queries, I will write to your emails and
definitely
I'll contact. Okay.
Please feel free. Our email ID is contact@devop-trics.com.
devop-trics.com. Yeah. Thank you very much for your time. Thank you.
No worries. Thanks for your question. Good question. Anyone else? In that case, Madhu, I would like to take the screen control and just show some of the courses that we have, which can definitely help people. Okay.
Okay. Sure.
Yeah.
Thanks for welcoming.
All right. Thanks a lot, Madhu. So, guys, if you can see my screen now, so on our website, you will be able to see the courses that we have. It's like devop-trics.com/courses. So most of the courses that we have, I mean, that is designed for specific specific audience. You can go to the details of this course. Okay, for example, if you go with this, okay, so this is specifically designed for the people who are right now into manual testing. They have never done automation testing, but they want to give it a start. Okay, so this will be there is a curriculum very well defined, that Java basics, Selenium, Git, Maven, TestNG, SQLite, and extend reports. So this is like good enough to start with. But there are some more serious courses like UI web and mobile automator, and this is like all-round automator, which is a great course that we have designed and which comes at a price which is even lesser than a smartphone. So if you see this, the course content is really very in-depth, and we will be talking about not only Java, but we will be talking about APM and Protractor also, with backend of SQLite and MySQL. And we will be talking about the BDD with Cucumber in depth. Also, we will be learning some JavaScript, which is really required for Protractor. And I would just like to say that if anybody does not know what Protractor is, it's a tool for automating typically the UI for AngularJS kind of applications. Okay, so this is kind of a very holistic view of test automation, and it will teach you Jenkins along with JMeter also. Okay, so this a new batch is starting on 22nd Jan, and if somebody is only interested towards the DevOps and they are like already into test automation and all, yeah, not necessarily a tester, but even a developer, we have a course for the DevOps also, which is specifically specifically designed for the ops part of the DevOps, which is like all the infrastructure management through learning Python. Then we'll be talking about the Linux basics, Vagrant and VirtualBox, Docker, Ansible, and we will see how to do the monitoring with Splunk and Nagios. So, and if you are a fresher and you are looking towards getting inside this IT industry, there is a very good classroom course that we have. It's like our flagship course, and it's a very, very, very detailed course. Go to our website, have a look at it, and we even assist you with the interview preparation, and we help you with job assistance also, and we help you arrange the interviews with many of the multinational companies that we work with. If you're really good, you will crack it, and we will make you that good. Well, this is what I wanted to cover. This is our goal and focus is to build workforce which is kind of very, very tech savvy, and we are focusing on the test automation and the quality aspect of it, because we believe that quality is really, really important. Developers are also, development is also important, but testing, nothing can replace testing, and without testing and without good quality, a software is nothing basically. So that's where our focus is, and we will be soon introducing many other courses. So visit our website, have a look at the courses that we have. Have a look at if you are a corporate and you want to start a corporate training within your premises, we do that as well. So you can go to the corporates page of our website and see what we do. So we do training, consulting, as well as staffing. So that's who we are. So thanks guys for attending this webinar. If anyone has any more questions, please feel free to bring it out. We'll be glad to answer that. If not, then we will just close this session. Okay, I think then let's close this session, and thanks a lot for joining this session. In advance, happy Pongal and happy Sankranti. And we will not have a webinar next weekend, but we will be having it after that weekend. So on 20th, we will have another webinar when people are back from the Sankranti, so that we can help them. So every weekend we are trying to have a webinar organized so that it helps people. So keep joining, keep learning, okay? And let us know wherever we can help. Shoot your questions to contact@devop-trics.com. We will be glad to assist you with your questions. So thanks a lot, people. Madhu, you want to sign off, say something to the crowd?
Yeah, thank you very much, team. And stay tuned for more knowledge sharing on new aspects of DevOps and continuous delivery. Thank you.
Thanks for the great questions also. Bye.